welcome back to day two. I'm Brandon Ribic, the Technology Director at America Makes, and I'm joined with my colleague, Mark Norfolk from Fabrisonic. Mark, it's good to see you, sir. How have you been?
Great, fantastic. Yeah, it's nice to be at a show where we can actually see people, talk to people, touch people. Yeah.
Absolutely. There's so much going on at the show over the last day and a half. Has there been anything that you've seen that's really stood out to you?
Yeah, we've seen a lot of interest from folks kind of in allied processes or in using multiple processes to make a part. So taking powder bed and using maybe a DED process in combination, or using our ultrasonic additive process with a powder bed to make a shape that you couldn't get from a single process, and that's kind of new and exciting.
Yeah, that is. It's funny you mentioned that. So we've done a little bit of work in that space a few years ago, but we're trying to understand the utility there. But the great news is it's understood, right?
Sure.
And I think that's what makes it so exciting is let's use the tools where they make sense and derive the best benefit from them.
Yeah, if you look at your machine shop right now, you have a drill press, a mill, a lathe. 10, 15 years from now, you're going to have an EOS, an Optimec, and a Fabrisonic machine all in the same shop, and you use them for what they're good for. Not one process does everything. Let's combine them and get the product that we're looking for. By using multiple processes.
Yeah. No, that's awesome. So, what's been going on at Fabrisonic lately?
Yeah, so Fabrisonic, over the last year, we've actually doubled in size. So it's been kind of fun. Right before COVID, we were kind of inundated with a lot of new jobs. A lot of that activity has been in embedded electronics, embedded sensors.
Okay.
Our welding process happens at a very low temperature, say 150 F. So we're printing metal at almost room temperature. So that allows us the ability to drop in an electronics package, a sensor, into a part as we're building. Things like health monitoring. So you put sensors in your part so that you can understand its health over time. Internet of Things. And also, we have a cool application for powder bed fusion.
Cool.
Right now, we're taking fiber optic cables that we can use as a strain measurement, and we're dropping those into a build. We're actually printing build plates for powder bed fusion. So we embed a fiber optic strain gauge into a build plate, and then when you're doing your powder bed fusion, you can actually get strain data out of that build plate as you're printing.
Oh wow!
So a lot of interesting sensor activity. Burying sensors in solid metal to get some piece of data that you couldn't get otherwise.
That's really interesting. Do you find that when people are utilizing that technique, is it for model development and validation, or is it for process development?
And we get all kinds.
Okay.
So I'd say about a third of the parts we make are actually used in process so that they can understand what's going on in the process and monitor the health of the part over time.
Okay.
The other third is that model validation that you're talking about. Everyone has these great FEA analytical models, but there's always a tweaker value in there, a little cheater value. And actually getting data from inside the part allows you to tweak that variable and get the model dialed in.
Absolutely.
Exactly.
No, and I think what I've seen, at least in the last year or so, a lot of people are trying to figure out, how do I get to that real-time data, right?
Yep.
Yeah, no, that's huge. You mentioned the health monitoring, and there's a lot of great benefits to the low temperatures that you achieve during the process.
Yeah.
I guess, are you seeing strong demand in certain industries for that type of capability versus others, or is it all over?
It's kind of all over the map. We have stuff in oil and gas, aerospace, nuclear reactors, and even automotive. So it kind of a mix, solving specific problems where they occur.
Yeah. No, that's cool. So, speaking about trying to use the technology where it makes sense and recognizing there are folks out there who think of additive as an allied process to welding, are there people who are looking at your technology for joining needs?
Yeah, so our technology is basically printing metal at low temperature.
Okay.
But you could also use that for welding metals at low temperature. So one example of that is we're getting a lot of people approaching us to take metal A and clad it on metal B. It's a single weld, so it's not really additive, but it's in the same system using the same technology. So we're actually kind of expanding our business outside of just strictly additive and looking at specific welding problems, typically in dissimilar metals, trying to put a thin coating, cladding, or join metal A to metal B. So it's an interesting evolution in the market.
Yeah. Do you see that So I think historically a lot of folks in automotive and energy have liked those types of opportunities or
Yeah.
utilize those design techniques.
Yeah.
Are you seeing interest from folks in spacecraft as well?
Oh, for sure.
Yeah.
Yeah, we do a lot of work in kind of thermal management as well as dissimilar electronics inside of aircraft.
Okay.
So joining those dissimilar metals, layering thin foils so that maybe you can get a flexible element for both thermal and electronic.
That's cool.
So there's a lot of carryover, from the work that we're doing strictly on electronics into aerospace components.
Yeah. Wow, that's great. It sounds like there's a lot of good things going on and a lot of growth at Fabrisonic right now.
We're having a ton of fun right now. The only plug I would make is we're looking for people. So if anyone's looking for a job, Fabrisonic's hiring. I think as everyone else is. So.
Yeah, that's great. Thank you. Well, Mark, it's so good to see you, and I hope you enjoy the rest of your time at Rapid.
Hey, thanks for having me.
You're welcome.